Okay, for section 6.3, we're going to calculate the confidence intervals for population proportions. A population proportion is the point estimate for P, which we know is the probability of success. So it is the proportion of successes. It is given by the portion of successes in a sample and is denoted by P with the caret symbol on top equals X divided by N. So P represents your population proportion. P with this little symbol on top represents your your sample proportion. X is your number of successes. N, of course, is the sample size. So it is the number in the sample. And the point estimate for the population proportion of failures, we know normally failures is Q. So here we're going to use Q with that caret on top equals 1 minus the sample proportion. Because we know that these two together have to equal 1. Probability of success plus the probability of failure. The following symbols, we don't read them, P with a caret on top or Q with a caret on top. It looks like each of them is wearing a hat. So we actually call them P hat and Q hat. Okay, so in the first few, we're actually just going to calculate P hat and Q hat. It's very easy math. It's not very difficult at all, but it says in a survey of 1,024 adults from the United States, 122 said they were not confident that the food they ate in the United States was safe. So P hat is X divided by N. So we take 122, we divide by 1,024. We get 0.119. Q hat comes from 1 minus P hat. So we do 1 minus 0.119, we get 0.881. And number 2, again, P hat is X divided by N. And let's see, we have 501 believed the role of unions protecting workers' rights was important. Our sample size was 1,001. We get 0.5. Q hat then, again, is 1 minus P hat, because P hat plus Q hat has to equal 1. So we got 0.5. Number 3, P hat is X again divided by N. And we get 2,634 divided by 4,105. And we get 64%. So Q hat, again, is 1 minus P hat, 1 minus 0.64, gives us 36% for Q hat. Okay, very easy. And there will be a question on the test where you do have to calculate both P hat and Q hat. Okay, so we actually calculated our confidence intervals. You don't need to know the calculations because, again, they will be, there is a calculator shortcut. But what we do is we take our sample proportion and we subtract our critical value, which will be a z-score. We multiply by the square root of P hat times Q hat divided by N. We're calculating where our actual population proportion will be, or estimating where it will be. And then the right endpoint is the same, of course, but with a plus instead of minus. Okay, so we're going to go back into our calculators. Notice we hit stat, we scroll to test, and we scroll down to this 1 proportion z-int. Okay, the way that we'll know that we are using 1 proportion z interval is because the problems will normally state that it's a portion. You're not going to be given a mean, and you will not be given a standard deviation in any of these questions. You'll just have 2 numbers, a sample size and some number of successes. If you are only given an X, a number of successes, and a sample size, then we know that we are using one proportion Z interval. Because again, on the test, now you're going to have to distinguish, do I use Z interval, T interval, or this proportion? So we're going to go back and use the statistics from number 1. We're going to calculate a 95% confidence interval and also a 99. We're going to compare the two. So I'm going to go to Stat. I'm going to scroll over to Tests. And now I need to find this one proportion Z interval. It is not 5. That's one proportion Z test. Here it is, one proportion Z INT. It is option A. So back in number 1, it said that X was 122 and N was 1024, and our confidence level, we want to start with 95. We go to calculate, just write down exactly what the calculator gives you. We get 0.0993 to 0.13898. Now, it also wants a 99%. So we go back to our test. Now I remember that it was option A. So a shortcut here is I could just hit alpha and the letter A, and it brings me right into that one proportion Z interval. X and N are the same, but this time we want 99%. And here's our interval. Okay, and then it says which interval is wider. The 99% confidence interval is wider. Okay, now if we wanted to write out one of these as a statement, because again, you will in the test, the questions don't ask you to, but let's take this 95% one, and I'm just choosing it at random. We would start the same. There is a 95% chance, and then there are a couple of ways of wording the population proportion. One way is just saying the population proportion and then the topic from this one was the amount of adults in the United States that believe the food they eat was not safe. So there's a 95% chance the population proportion of U.S. adults who believe the food they eat is not safe is between, and now these are percentages, so I'm actually going to convert it. I'm going to say 9.93% and 13.898%. Now, students in the past have said, well, can't I just round to 10% and 14%? That's fine if you do that in the statement. I don't mind. Okay, now in number 5, again, we want to calculate the 95% confidence interval and the 99% confidence interval and go back to example 2 for that information. So we're calculating for proportion. I'm going to hit alpha A in my tests. It brings me to my one proportion Z interval. We have 501 was our number of successes out of 1001. We want a 95% confidence interval. I hit calculate. So we get 0.46953 to 0.53147. Then I'm going to go to my stat and tests. My X and N are the same, but this time we want 99%. And there's our 99% confidence interval. And again, the 99% confidence interval has the wider range. Okay, let's take the 99% one and write it out as a statement. We would say there is a 99% chance, and then instead of saying the population proportion, you could state the true proportion. Of, again, this is U.S. adults who believe, oops, we don't need an S here, who believe that unions, who believe the role of unions in protecting workers' rights is as important today as it was in the past. Is between. This time I'll round it, excuse me, just to show you that you can, 46% and 54%. Okay. Number 6. We're going to go back and use the information from example 3. So I go to stat and tests. X was 2,634. N was 4,115. I'll do the 95% confidence interval first. Then I'm going to go back into the test, change my C level to 99, and again, when we compare these two, this bottom one has a wider range or a larger range, so the 99% confidence interval is wider. And again, the 99% confidence interval will always be wider because we're talking about 95% in the middle and where P falls versus these P hats that we have. And 99% definitely has a wider portion underneath the curve.